All right, so we're going to talk about drag, one of the forces. It goes in the opposite direction of motion. So if you're running forward and there's a big headwind, you can think of that's the drag force that's kind of pushing you back. Here's the equation. It seems like a complicated equation, but just look, we're going to go through each of these features and how much they affect the drag. And just note this v squared, which tells us that velocity, this is the relative velocity, has quite an impact on drag. The first one is this coefficient of drag, and it has to do with the roughness of surface. We'll talk about that. The density of the fluid affects your drag, the area of the object or the profile of the object hitting the fluid, and then the relative velocity. So the first is this coefficient. You can have surface drag, which is your skin friction. Roughness of the surface. So basically you want to decrease the roughness. So people shave, right? Swimmers and cyclists. Clothing has changed a lot. There's more form-fitting clothing, no seams, no zippers. It's gotten very high-tech. You can think of just runners, right? We used to run in flowy t-shirts and shorts, and now everybody has tight shorts and tighter tank tops or Under Armour type clothing. Then the viscosity of the fluid, which is hard to change, but there is a certain temperature range that pools must be in during competition so the viscosity is consistent from meet to meet. This concept of wave drag tends to be for airplanes, but it's also saying swimmers, if they are on the surface of the water and create waves, or way back in the day with the older pools where you never wanted to be on the outside lanes because of the flow back from the gutters that would cause waves. That's the wave drag. You also have form drag. You want the fluid to roll over the surface and not create turbulent flow. So here are these terms again. Laminar flow, nice and smooth, streamlined, and turbulent flow. This is how I would dive in. Head up, all kinds of turbulent flow slowing you down. And here's a comparison of four profiles. A flat plate, so you can imagine you're on a beach cruiser, so your torso is completely up, hitting the wind. It's a huge drag, lots of turbulent flow. A sphere is a bit better. This whole idea of streamlining the back of an object also decreases this turbulent flow, but the most optimal is this eyeball shape. And think of the change in bike helmets. If you look at time trialists, they have a very similar shape to their helmet as this bottom object. The final one is relative velocity, and drafting in certain sports, even running, decreases this relative velocity. And velocity is the largest contributor to drag. So if you have an opportunity to watch a race, and they talk about the peloton, and so the peloton is when all the racers come together and kind of ride as one, and they can get super fast because they are decreasing this relative velocity. And so even on a smaller mini peloton, if you will, you have riders very close to each other, and the first rider is taking the big hit in drag, but overall, the relative velocity between all these other riders is much less. So they can, as a group, go much, much faster. And then this person will peel off and somebody else will take the front position. But just decreasing this relative velocity through drafting really increases the speed of all the riders combined.